Can you imagine a city beyond the confines of Earth floating in the vast expanse of space? Picture this, a bustling metropolis not on the surface of our planet, but suspended in the endless cosmic ocean. These are space cities, the next frontier in human exploration and colonization. They're not just figments of science fiction but potential realities of our future. In this exploration of space cities, we'll delve into the architectural and design considerations that shape these celestial settlements. We'll scout potential locations from lunar bases to Martian colonies and orbital habitats. We'll probe into the essential technologies for sustaining life, and discuss the economic aspects that could make these cities not just viable, but thriving hubs of industry and trade. We'll also touch on the exciting prospects of space tourism, the engineering challenges, the legal framework, and the social and psychological aspects of life beyond Earth's atmosphere. Join us as we embark on this journey to explore the cities of the future, in space. In the realm of space, architecture takes on a whole new dimension. As we venture into the cosmos, the design of our future abodes must adapt to the unique challenges that space presents. One of the most critical considerations is radiation protection. Without the protective shield of Earth's atmosphere, space cities would be exposed to harmful cosmic rays, necessitating innovative shielding solutions. Next, we grapple with the absence of gravity. To replicate the conditions we're used to on Earth, space habitats could employ artificial gravity, potentially achieved by rotating parts of the structure. This would not only enhance comfort, but also mitigate the adverse health effects of prolonged weightlessness. Lastly, space is vast, but inside a spacecraft, it's quite the opposite. Efficient use of space is paramount. Every square inch should be meticulously planned to maximize utility and accommodate essential life support systems, storage, and living quarters. In space, functionality and survival are the cornerstones of design. This encapsulates the essence of space architecture, where every element serves a purpose and contributes to our survival in the final frontier. Where would we build these celestial cities? A question that sparks intrigue. Let's take a closer look at some potential locations for our future space cities. First on the list is our closest neighbor, the Moon. Establishing a lunar base may seem like a giant leap, but it offers a shorter commute and a familiar celestial body to study and learn from. However, limited resources and harsh conditions present challenges for long-term habitation. Next, we have Mars, a planet that has captured human imagination for centuries. Mars offers more resources than the Moon and a day-night cycle similar to Earth. But the distance from Earth and the thin Martian atmosphere pose significant hurdles. Lastly, we consider orbital habitats, cities floating in space. These habitats could be located anywhere, providing flexibility, but they would rely solely on resources brought from Earth or harvested from asteroids. Each location has its own unique advantages and disadvantages, presenting exciting challenges for future space architects. Location is key, even in the vastness of space. How would we sustain life in these extraterrestrial metropolises? As we step into the future, this question becomes increasingly relevant. The answer lies in the sophisticated technologies and systems engineered for long-term sustainability and life support in space cities. Consider food production. We're not just talking about growing veggies in a greenhouse, it's about developing advanced hydroponics and aeroponic systems. These technologies will allow us to cultivate food in microgravity using minimal resources. Then there's waste management, a critical component of any closed ecosystem. From recycling water to composting bio-waste, we'll need to imitate Earth's natural cycles as closely as possible. And let's not forget about air supply. Our lives hinge on a delicate balance of gases, oxygen, nitrogen, and a dash of others. In space cities, maintaining this balance will require real-time monitoring and control systems, ensuring every breath is as good as the last. Life support is a complex puzzle that we must solve to ensure our survival in space. Is there an economic case for building cities in space, you might wonder? Well, let's dive into the economics of space cities. The prospect of space cities opens up a myriad of potential industries. From mining asteroids for precious metals to farming in zero gravity, the possibilities are as vast as space itself. In terms of trade, space cities could become crucial hubs. Imagine a city in space as a pit stop, where spacecraft can refuel and resupply before venturing deeper into the cosmos. And let's not forget the potential for tourism, which we'll delve into more in our next segment. Financial models for space cities are still in the speculative stage, but it's not hard to envision a future where space city economies thrive on the exchange of goods, services, and even intellectual property rights. So, while the initial investment may be astronomical, the potential returns could be out of this world. Space cities could be the next frontier for economic growth. Could space cities become the ultimate vacation destination? As we stand on the cusp of a new era in space travel, this question is no longer as fantastical as it once seemed. The burgeoning industry of space tourism is already making strides, with private companies offering up a tantalizing glimpse of what a holiday in the cosmos could look like. Space cities could offer tourists a unique experience, far removed from traditional earthly vacations. Imagine, for instance, observing the Earth from an orbital habitat or walking on the surface of the Moon or Mars. The exotic allure of these experiences could drive the development of space cities as demand for space tourism grows. Moreover, space cities could serve as hubs for space travelers, providing essential amenities and services, much like our cities do here on Earth. The economic implications are immense, potentially providing a significant financial incentive for the construction and maintenance of these celestial metropolises. Space tourism could be the catalyst that propels us towards building cities in space. What are the hurdles we need to overcome to build cities in space? This is a question that keeps scientists and engineers up all night. One of the biggest challenges is the transport of materials. The cost of launching just 1 pound of payload into space is astronomical, pun intended. This means we need to figure out how to use resources already available in space, or develop new, lighter materials. Then there's the question of construction in microgravity. Traditional building methods won't work in a zero-gravity environment. We'll need to create new techniques, possibly employing robots or even 3D printing technology to assemble our space cities. And let's not forget about maintenance. Space is a harsh environment, with extreme temperatures, radiation, and the risk of micrometeoroid impacts. Our space cities will need to be tough, but also adaptable and self-repairing to some extent. The challenges are immense, but not insurmountable. With human ingenuity and perseverance, the dream of space cities may become a reality. Who would govern these cities in the cosmos? This question takes us into the realm of space law, a fascinating and complex field that's still in its infancy. Space law will undoubtedly play a critical role in the governance of space cities. We must consider property rights. Who owns the land on which a space city is built? The Outer Space Treaty of 1967 stipulates that outer space, including the Moon and other celestial bodies, is not subject to national appropriation. This means that no country can claim ownership. But what about private entities or individuals? Then there's the issue of international cooperation. Space exploration has historically been a collaborative endeavor, and the governance of space cities should reflect this. A system that encourages cooperation and mutual benefit is essential. In conclusion, governing space cities involves navigating uncharted legal territory. The laws we have on Earth may not suffice, and in space we need a new framework for law and order. How would living in space affect us, psychologically and socially? This question is at the forefront of our minds as we envision life beyond Earth. In the microgravity of space cities, our daily routines, social norms, and even our sense of self would be transformed. The isolation and confinement of a space city could pose significant psychological challenges. Long-term exposure to these conditions could lead to feelings of loneliness, monotony, and stress. It would be essential to design environments and routines that foster social connections and offer mental stimulation to mitigate these effects. Moreover, the social dynamics within a space city could evolve in fascinating ways. In the absence of traditional geographical and cultural boundaries, new forms of community and cooperation could emerge. The unique challenges of space living could foster a heightened sense of collective identity and mutual dependence. Life in space will undoubtedly reshape our social and psychological landscape. As we push the boundaries of human habitation, we are also pushing the boundaries of the human experience. What does the future hold for cities in space? As we move into an era of cosmic colonization, space cities are poised to play a pivotal role. They will be the heart of humanity's expansion into the cosmos, becoming hubs of life and activity far from our home planet. The potential impact on our future is immense, with the possibility of resource acquisition, scientific discovery, and the safeguarding of human existence against earthly disasters. Space cities also present exciting opportunities. Imagine a future where children are born and raised on Mars, where lunar vacations are commonplace, or where orbital habitats become hotspots of interstellar trade and culture. The possibilities are as vast as the universe itself. But none of this will be easy. It will require advancements in technology, international cooperation, and a pioneering spirit. Yet, as history has shown, humanity is up for the challenge. As we gaze into the cosmos, we see a future where humanity is not confined to one planet but spread across the stars.